Hello and welcome to the first episode of The Corner Case. We've got nobody dialed in just yet, so this could be a short and abortive podcast. Oh wait, we have our first user. If you're listening via YouTube, you can find the Hangouts link on the YouTube page and on Reddit and Twitter. Join if you're interested, and then send me a message in the Hangouts chat with what your issue is and how I can help, and we'll unmute you when we're ready. Also, if you don't want to join the Hangout, but you do have a quick question, feel free to ask it in the YouTube live chat. So our first caller is Karen Scarborough. You're currently muted. Do you want to unmute yourself and ask the question so everyone else can hear? Maybe dealing with some minor technical issues with YouTube Live here. Karen's question is, she says she's wondering about some design principles with ERC 721. What's the best design to use when you want to create multiple ERC 721s at the same time? So let's start by having a look at 721 itself. And so 721 is the non-fungible token standard as used famously by CryptoKitties and possibly others. So on its own, it defines a reasonably simple interface, which includes ways to access the tokens, but does not intrinsically provide a way to issue tokens, which is up to the individual token creator. Sorry. So in general, what I'd suggest is if you're trying to create a batch, you can add your own interface for batch creation of tokens, which can contain solidity arrays and so forth of all of the necessary parameters, which of course are going to be specific to your particular application. One thing you might consider is whether you can do effectively offline creation in a sort of an airdrop fashion. You can generate a signed message that authorizes creating a particular token and then send that signed message to the user, who can then submit it themselves to the contract. And that can save you a lot of gas by setting up a situation where the users have to create the token instead, because naturally anything that involves populating a large number of values on your own contract is going to take up a lot of gas if you do it yourself naively. Since we seem to be having audio problems, let me know whether that was of any help and whether I can expand on any of it. Okay, so let me expand a little on the offline part while we're on the subject. There's a number of ways to deal with offline transaction signing, with signing of messages that can be easily verified by smart contracts. One of the issues with this is that there are two different RPCs for signing messages at the moment. There's private sign and eth sign. They both produce different results because they prefix different strings. And even worse, there are multiple different implementations across different clients that prefix different strings. And this can lead to a lot of trouble with getting it to work compatibly in your client. The thing that I've found works best is to use JavaScript in the browser and sign it using a key that that you control through MetaMask's provider interface or directly through using the signing libraries. And that gives you complete control over what you're signing. There's also a relevant EIP for a format for signatures, whose number is escaping momentarily. I will post to the chat when I have a chance to look it up later. So we have another caller. Yes, 191, I believe, is the correct one. Hang on. And I'm being, yep, you're correct. ERC Signed Data Standard 191. It specifies a format that's compatible with the legacy Ethereum signed message prefix string, but also allows for a simpler version that's easier to pass inside a smart contract. So yes, we have another caller, John Madlin. How can I help you?
I just wanted to see what's happening here.
All right. You don't have any design questions?
Okay. So something that's been design questions. Let me see. Yeah, I guess I'm curious about constructors and constant and immutable values. So this is more just something that's been bothering me lately, and I thought you might have some thoughts about it. But so generally, when you have a often people will declare storage variables, like let's say in a token, 18 decimals. That never should change, but they always use a storage slot for that. And often that's because they want to be able to change, like maybe they want 20 decimals, or they think in the future they might want 20 decimals, and they want to be able to specify that in like a truffle script when they're deploying it. And so like I have this thinking about, like I'm just curious if you've thought about that kind of, like, it seems like the constructor lacks some separation of, or it's just like constructors, I think, are being abused, and people are using it to because there's not a simple way to set values without editing a solidity file. They're using the constructor to do that. Maybe here, let me ask you this: do you think it would be good if there was something like a template kind of language, almost like a JavaScript template string, where I could drop it in and say equals, $, curly braces, decimals, and then outside in the contracts directory, it was just like a JSON file where I could say decimals 18.
So I think there's a couple of ways to handle it. That's one way, definitely, with a preprocessor. Generally, I personally think preprocessors are a little bit ugly. They tend to lead to, or you end up with multiple stages of compilation and so on. You could build one on top of Solidity now using like the C preprocessor or a templating language or whatever. I wonder if a neater solution would be support in Solidity for effectively read-only or construction time variable scope, where because Solidity, unlike most languages, has this distinction between construction time and runtime. And a constructor could, in fact, generate bytecode that embeds the constant in the final bytecode, and then you would read it out of your local contract data instead of reading it out of storage. which would, save you 20k gas or so on construction time and a little bit of gas every time you read it. So I wonder if a better approach would be a solidity feature to be able to scope a variable as can only be written in the constructor. And that would cause the compiler to then, substitute it into the bytecode somewhere, like into a table of symbols at the end of the contract, for instance.
And do you think that could be, that seems like on-chain, that seems kind of tricky, because you would, like, the way I thought that might look is that you'd, I guess, maybe just have zeros or some kind of like, some bytecode marker, not quite like underscore library name, but something that never should exist in bytecode. And then on chain, you would do some work to like find the program counter location, and then insert it. So it would add complexity, right, to the constructor.
So it shouldn't. The constructor shouldn't have to search for it, because the compiler knows where that constant ended up. So the constructor just needs to know the location in the bytecode to substitute it into. You could possibly work around even that by just saying by convention that all the constants will be located at the end of the data area, and therefore that they'll it can just append it to the data before returning it. That would make the code to load the constant a little more complicated and therefore require a few extra gas. It would have to, load contract lengths.
Jump around to push it on and then jump back, or? Well,
there's sort of two ways it can be embedded. One is with a push instruction, but the other is that you can actually just do the opcode to load your own bytecode. I need to double check. Hang on, let me have a look at the Ethereum. The beige paper. I'm actually a big fan of the beige paper. It's
awesome.
If you're not familiar already, it's a rewrite of the yellow paper to be more readable. And yes, let me have a quick look at the opcode section at the end of that. The other great opcode reference is the Solidity docs on inline assembly, where it provides a list of all the opcodes and their input parameters.
I find that actually better because it has the inputs.
Yes, really exactly. Like yep. And in fact, yes, I can see here that code copy takes 3 parameters, but not what those are. I'm pretty certain I know what they are, but if I look them up in the Solidity assembly section, I can tell for sure. And so they are
like size. Okay, yep. Go
ahead. From position F, copy S bytes from code at position F. Position T. So grab just, say, a 32-byte section of the bytecode, so you can embed your constants into an unexecutable area of the code. And that's something I don't believe Solidity makes heavy use of at the moment, but is a good way to store, constants that might be accessed in many places, I think.
Yeah, that would be really awesome. As it drives me, it feels like there are we could be, it's very rare that you can be safer and save gas, and in this case you can. So and there was go ahead.
I would love a way to generate runtime code more in general. There's a lot of things you could do if you could easily generate contracts at runtime. For instance, writing a lot of data to storage that never gets changed costs 20,000 gas per word. Writing that to contract storage is a lot cheaper. So in principle, you could write like a generic hash map contract. You give it a bunch of data, and it creates a new custom contract that only answers questions about that data. And that would be cheaper in gas than actually storing that data in storage, as long as you didn't modify it. It was write once.
I don't think I'll be honest. I fully understand that.
So suppose, thinking of my Ether cards, for instance, I want to upload a list of hashed addresses for Ether cards to say, I claim I printed all of these. And presently what I do is I use up 1 storage slot per Ether card, saying, this is the, this is the hash of the address of each Ether card. But 1 storage slot is 20,000 gas. In principle, for each new one, I could create a contract that just answers yes to all of the hashes and no to everything else. It would be basically a hash table implemented in code, and it would be significantly cheaper than 20,000 gas per entry.
Right. Okay. So just generally, the concept of putting data in the bytecode more often, it's a
Yeah.
completely immutable contract. Um, yeah, and it's just some getters basically.
Yep. Precisely.
Yeah, I really like that code
Aspirin tree.
copy approach. Right. Okay. So just generally, the concept of
Sorry, muted now. No worries.
oh, that was the YouTube sort of like live play in the background of my voice. I understand why I just heard my words again. What do you? Okay, and then like the last. So, I think like what would be nice is maybe having an immutable keyword. I forget the use of this. Why doesn't constant just work? I'm not sure, but
so that's a good question. As it stands, Solidity implements constant using just regular variables, but I don't think it allows you to assign to a constant from a constructor parameter. It has to be set at compile time. What you really want is something that can be written once at at construction time and never again.
So you think that would be a different I don't know if type is the word, but the thing to do is not change the way constants are set, but to create a new type keyword.
Yeah, I think I'd want to pump that to the Solidity language designers, because there could be unexpected consequences there. But changing the way any existing language feature behaves can be dangerous. So I'd be more inclined to introduce a new one, even if it means deprecating the old one. Yeah. But arguably they have different cases. Like in theory, you should always be able to optimize away the constant, and just inline it. So it may still be useful to have that.
Cool. Yeah, that was. I don't know. Maybe Karen has more questions, so I should.
Yeah, let me go briefly back to Karen, who said something else on the chat. She said, I'm thinking of cases like having a piece of real estate being represented by tokens, won't say 1 token per square meter or square mile, because there's a benefit to having small denominations, but the challenge of creating a lot of tokens if a user wanted to purchase a large amount. So in that case, I would suggest that what you want is a token contract for your chunk of land, and you want a regular ERC20 fungible token contract, and you can issue as many as you want with just a single operation. If you want to represent a lot of different parcels of land, then each parcel as a whole could be represented by an ERC 721 token. If there are useful operations you can carry out on a whole parcel, like, I don't know, registering it with the online version of the council or the blockchain version of the council. So in that situation, what you'd effectively have is a ERC 721 contract with a token for each parcel, and that token is controlled by its own ERC20 fungible token. So actions could only be taken on the parcel as a whole if a quorum of token holders agreed, for instance. And that may be a little more complex, but it provides for both, effectively being able to divide things up as small as you want, while still retaining control over the whole thing. And I'm just discovering that Google Backup and Sync is chewing through all of my batteries, so hopefully we don't go offline before the end of the hour. So just a reminder that if you're listening in on the chat, the Hangout could be joined via the links I pasted in the YouTube channel and the chat there, and on Twitter and Reddit. Richard Brady joined us earlier briefly and his microphone was unmuted, but that's my fault because I had the wrong settings. Feel free to rejoin if you have a question to ask.
Okay, while we wait for someone else, I have a question that came up that somebody else was asking, and I didn't quite know how to answer the other day, about if there's a standard way to notify contracts about some action happening. So I've seen this in plays, and I have I thought I saw this in the ETHCC ERC777 presentation, but I looked quickly at that at the actual spec, and it did not refer to hooks in the way that the recorded presentation did. So yeah, is there a best practice or a standard for that?
So not that I'm aware of. There's various different proposals have defined specific options for hooks, in that particular standard. So for instance, ERC 777, one of the proposed new token contract standards, offers a way to notify a contract when it receives tokens, and also ways for addresses and contracts to say, specify their preferences about sending or receiving tokens. So that's sorry, one second. So generally, I'm not aware of a general purpose version of this. I've suggested that before that we should have a generic metadata registry for addresses, so that you can associate whatever address you want with whatever metadata is relevant. So basically either a resolver pattern like ENS uses, or just an ordinary dictionary lookup, and we could standardize hooks there. I think this is an area that's rich for sort of further thought and standardization. So if you have an idea, open an EAP, or at least open an issue on the EAPS repository where we can discuss it in more detail. And I'm just going to go to Karen briefly for any further thoughts on ERC 721 tokens. Hello.
Oh, okay, great. I think it's working now, right?
It is, yes.
Good. Right. Well, I think I got out most of my questions around things. It was mainly around how do you take advantage of the non-fungibility of ERC 721 while still having the ability to have smaller denominations from something like an ERC 20, and the thought that you mentioned behind having the ERC 721 representing several ERC 20s seems to make a lot of sense. So that helped a lot there. Really, other than that, I'm just here to learn. So if I come up with more, but I like the discussion that John had around writing the variables directly in the constructor. That's really interesting.
Yeah, I think both are areas that we're going to see hopefully better development of in the near future. And I don't think you're the only person wanting to deal with combination of 721 and ERC20 tokens. It's a pattern I've seen mentioned by other people before. So hopefully in not too very long, we'll see contracts that facilitate that you can build on, rather than having to everyone having to do it for themselves from scratch.
Right. Good.
I'll jump in there quickly. I think I put a note on the YouTube, which was sort of like with your example of land parcels. If you own multiple ERC 721 tokens, that let's say that your parameters are like X and Y, it's on a grid and you have a matrix. If you own 4 blocks in a square, can you combine them to create one bigger block? I think that's and that doesn't require going back to an ERC20. It's just, you could just have a smart contract that combines ERC 721s to create a new ERC 721. So I don't know if that was kind of what you were alluding to, Karen, but I thought that was quite a cool idea of yours.
Right. I actually saw at ETH Denver, there was a team that made a representation of like 5 CryptoKitties as one ERC 721 for trading, so that you didn't have to transfer all 5 at the same time, which was pretty interesting. So I've seen that. It's just still the gas intensity of creating and moving everything at the end of the day is something that I want to try to avoid, because especially trying to create something like in this particular case, it's a conservation effort. So the idea is to get several people to buy into this land, and not everybody's going to spend a ton of money to buy into those kind of efforts. So allowing the ability for smaller amounts to be purchased and worked with is something we wanted to look at.
Cool.
I think it's worth bearing in mind too the fact that ultimately you want these tokens to reflect reality, and the idea of a contract being able to arbitrarily, split and combine units of land in whatever size is quite fun, but it may not reflect what the local authority considers to be the actual division of the land.
Right, that's true. That's true. Well, it's seeing what's possible now and what's doable, and working around that, and these new standards and options that are coming out offer a lot more ways to look at assets. So
yep,
seeing
absolutely.
if it can fit into the use case.
Agreed. Yeah. So Richard, did you come in with a question in mind?
No, I just was trying to work out where the chat was happening, because there's obviously a live chat on the YouTube, and I wasn't sure if there was also one on the Hangout.
Right.
Jumped on the Hangout just to see if there was another chat there. I don't have any particular question. Mine, I was wondering, you tweeted something about a new widget for taking Ether payments the other day.
Yes.
You played around for Ether cards, and I can't remember the name. It was ETH.
Yes, I can look it up if you give me 1 second.
But I was wondering if you found that it had any. Was it sort of like a fairly one size fits all solution, or did it have sort of options around styling and embedding and whatnot?
It didn't give you a lot of. So it's called Etherglade. It doesn't give you a lot of options with styling and embedding. Let me just present my screen so that everyone can see what we're talking about. So this is Etherglade, and you can see the sort of general styling here. It basically lets you optionally select an amount, a payment method. They currently support MetaMask, although that's rapidly becoming a term for just Web3 in the browser, and Ledger. And then they default populate an address. If you look at the documentation, they support a fair degree of customization. You can they have smart contract support. You can even you specify the ABI and then specify individual function arguments when you instantiate the entity. So you don't even need to mess around with encoded data and so on. They have various advanced options, but I don't think they give you a great deal of control over how the UI looks at the moment. I suspect that would be a welcome bit of feedback for them.
Yeah, although I mean, I think it's fantastic that they've created something that's just so simple, and you can just drop it in there. So all kudos to them for that.
Absolutely, yeah.
I think you have some questions. I don't have any more questions myself. I'm really just here to listen and learn. But I think there is a chap called Philippe asking in the on the YouTube side.
Yes, indeed. So he seems to have deleted the first part of his question. He says, I know you can simply encode everything together and call, but want it to be easy for people to interact with the function via Remix or MyCrypto, for example. I think we need more context from his original deleted message to say, to be able to answer. There was also a question, are there any major security in contract into 2 because of gas limits, where contract 2 is injected into contract 1's constructor, and then C1 wraps calls in functions in C2. Yes, there definitely are. Mostly in that your second contract, your contract 2 in this case, needs to do access control. It needs to make sure that anything it's doing is only accessible via the correct contract 1, which of course it doesn't know at instantiation time because it hasn't been created yet. In that sort of situation, I would suggest that you're better off using libraries. If your contract is then use Solidity's library support and link that in. It'll have similar sort of runtime cost effects, but it doesn't have the same issues that you have with data access, because the called library is never accessing its own data, it's accessing the caller's data. Philippe, I still can't see the first part of your question. Could you restate it, or you could maybe join the Hangout and ask it live?
In the meantime, I'll ask, why is your video not taken? Why have I kept the video floor? Oh, there you go, Robert.
Yep.
Maybe I'm behind on the YouTube.
No, because I'm manually switching things and I'm new to this whole podcasting thing.
Do you want me to ask another question in the meantime?
Sure, if you have one queued up, then by all means.
One thing I'm really curious about is payment channels in the browser using I don't know what. So the sort of opening your payment channel in the with an on-chain transaction, and then somehow from the browser you want to pass a off-chain update transaction to the counterparty, if you can call it that. So this is not necessarily for a fully decentralized app, but where your counterparty is, you want to do streaming money, it's for a video, for a call, or something like that. And what also, can you give me an idea of what the architecture would look for something like that?
So in general, it sounds like what you're talking about is a sort of a checkbook use case, where you only you're sending payments in one direction from you to the counterparty, or potentially vice versa. They're not bidirectional. Is that reasonably accurate?
Yeah, well, unidirectional payment channel.
Yep. So I mean, in that case, your payment channel itself can be extremely simple. You open it with a fixed deposit, and you only have to keep track of a check number or a nonce, and the total outstanding balance, and then you can send counterparty to close the checkbook by submitting it, or even just to update it and pick up the money so far. So unlike bidirectional channels, you don't need a closeout period. You don't need to worry about disputes and so on, because they're the only ones able to do that effectively. Although, sorry, as I say that, I realise that's not 100% accurate. You may want a situation in which you can recover your remaining funds in the absence of the checkbook creator submitting their signed message. So a closeout period may still be beneficial. What I'd suggest, and then of course you need to communicate those checks, the messages from you to the person you're paying. And what I'd suggest is that both of these are things that, for the moment, you're going to have to cook up yourself, but I'm aware of at least a couple of toolkits that are under development that will facilitate doing this more easily. And that in the, once those are available, then a lot of the work's done for you. But for now, you pretty much have to manually cook all of this up from scratch. And in particular, any sort of peer-to-peer communications for sending the messages for the state channel between you can be a real pain, unless you're happy to deal with a centralized intermediary like a website.
Yeah, so that's I guess that is the main thing, is like, what is the mechanism today for sending those updates? So if you are a website operator and you just want to be using Web3 to take payments for streaming content, that does simplify it. And also, if your payment channel is unidirectional, that does simplify it, because then the updates can just be sent through, I don't know, I guess a WebSocket or something like that. But I was just wondering what the sort of state of the art was in that. If there's any guidelines, can you tell us anything about those toolkits that you mentioned?
So I'm aware that SpankChain are coming out with one, which is going to be focused on I believe, unidirectional payments. Raiden, of course, are working on theirs, but we don't have any recent news on when that might be. And Funfair, with their Fate channels, I believe, were recently talking about a release in the near future. I'm fairly positive there's also another one that I've missed, but its name again completely escapes me.
That's great. That's plenty to go on.
Philippe has a question. Go ahead, Philippe.
Yeah, I just joined. Can you guys, girl, hear me?
We can indeed.
Perfect. Now as well?
Yes.
Okay. Sorry, I have a new microphone and it's buggy sometimes. Okay, so but I'm basically trying to, I'm gonna paste like a small Web3 RPC call in the chat. And I have a function, it's buying tokens, just like on a crowd sell. And I want to pass an argument, which is the person that the token should go to. But I also want to pass in the data a signature. And the reason I want to do all of this as a function call, not just put the signature as an argument, is because it's a function that there's a function call buy tokens I don't want to overwrite. So I'm passing complicated. I'm trying to make it simpler, but this is what I'm trying to do. Of course, I could just do web3.eth.call, encode the function, encode all the arguments, but I would rather so that people can just say, click on buy token, specify the address of the buyer, and pass as the extra data the signature. And I was wondering if that was possible, because so far I haven't been able to do it.
So, from the EVM point of view, when you call a smart contract inside a transaction, it gets only one parameter, which is the data field. So, in the example you're giving there, with you're calling this .crowdsale.buy tokens with a parameter and then also specific data. What will happen there is Web3 will either ignore your signature in the data, or it will overwrite the entire data field with that signature. And in the latter case, that means that it's no longer a call to the buy tokens function. It's just that signature data will be taken as the complete data of the transaction, so it won't be interpreted correctly. There's basically, for this case, in general, when you're calling a smart contract, you have the choice of either sending along raw payload data, which it interprets however it wants, or using Web3's functions to encode them for you. You can't combine the two like this. So ultimately, what I would suggest you have to do is provide an overload of buy tokens that takes two parameters, where one of them is the signature. Calling overloads from in Web3.js is a bit messy, but unfortunately, there's not really any way around it in this case. The alternative is that you rename your function to something else, like buy tokens with signature or buy tokens for other or something like that.
Right. Okay. No, that makes sense. So it's either that it overwrites the original data field, or it ignores it, but it cannot just append the data signature to the existing data. And then
That's right. Okay. That's correct. Yeah.
Makes sense. Okay. Thank you.
My pleasure. All right. Let's have another look at the YouTube channel. Our earlier submitter who was asking about splitting contracts, he says, regarding splitting a contract in two, you suggested using libraries. Did you mean making a library of contract two still being our own code, for example? Yes, that was what I had in mind. You know, how practical that is depends, of course, on what you're trying to achieve. I mean, generally, it's a bit broad to say this, but at the point where you're struggling with a contract being so large that you can't deploy it in the block gas limit, you may want to look more closely at what you're doing on chain and whether or not it's whether you're doing stuff on chain that you don't need to be doing on chain. Certainly, there are cases where you want to do something that's large and complicated, and there's no getting around that block size limit, or maybe the thing you want to do requires carrying along a lot of data in order to decode it, for instance. But in general, often if you look closely, you'll find you're doing things that you could probably do off chain and then just submit proof of it on chain. And also, any contract this large is probably going to be very hard to audit. So I may be insulting you. Your contract may be the neatest and tidiest ever, and therefore as small as it possibly can be. But before I started worrying about ways to optimize my contract and split it into two pieces and call it securely, I'd take a very close look at whether I can slim it down first. So, any further questions from our two still dialed in, Karen and Richard?
No, I'm good. Thank you. It's been really interesting.
Cool. And I'm just going to give people a chance in the YouTube chat to ask any further questions or call in. Otherwise, I guess it will be a short first episode.
Well, just while we have you, taking advantage of the time, it's a more general question, and it's something that I haven't looked at that much yet, but could you explain a bit behind how upgradable contracts work?
Mm-hmm. So there's a bunch of different approaches people have taken for upgradable contracts. All of them rely to one degree or another on some form of indirection. I would say that the simplest version from a technical point of view is to use something like ENS or another similar redirection and simply replace your contract en masse and then point to it from a stable identifier so that people can find it. This is pretty much the upgrade approach that things like EtherDelta have taken. They just deploy an entirely new version. They update their UI to point to the new one and tell people, withdraw all of your funds from the old one and migrate to the new one. So it's basically user-driven migration. There's a couple of other ways you can do it that are common. One is that you divide your data storage into one contract, which is then responsible for storing and retrieving data. Basically acts like a NoSQL data store or a storage system of some kind, and put all your logic in another. And then you can replace the logic contract without affecting any of the stored data. The side effect of this is that your users don't have the same guarantees what you're going to do with their data. If you have the right to replace the logic contract at will, then you can replace it with something that updates or deletes or replaces their data or does other things they didn't originally authorize. And that's a trade-off in most forms of upgradability, is that you're giving away some degree of control over, or you're reducing the effectiveness of restrictions on what you can do. And you can compensate for this. For instance, the ENS permanent registrar uses an upgrade pattern where we can deploy a new registrar, but you have to migrate your deposit over to it. And if you don't want to migrate your deposit over to it, you can get your money back. So you only transfer your name if you agree to the new premise of the contract. And the final upgrade mechanism that I see in common use is the sort of the proxy contract, which is almost the reverse of the database contract. So in that case, you have a very simple contract that basically forwards all calls to the implementation contract, the logic contract, using delegate call. So it has its own data storage, but relies on something else for logic that has the same caveats with regards to upgrading. But it provides a better interface to users because the address doesn't change. That's become more practical thanks to the recent Byzantium hard fork, because you can now return arbitrary data. You can build a proxy contract that just works for everything. But the caveat there is that basically you need to make each new version of the contract an extension of the old one because of the way Solidity allocates storage slots. If you're not careful, you can end up messing up your storage quite badly, and it can be more difficult to audit and more difficult to maintain effectively because Solidity wasn't really designed with this pattern in mind.
Okay, that's really helpful. There's a lot of different options there.
There is, and I hope someone, maybe me, will write a detailed post at some point with all of the options. Cool. I notice Philippe has rejoined. Did you have another question?
Yeah. So, well, I mean, if you're free, I can ask a couple of questions.
Sure.
So it was one question that is tangentially related to Solidity, and it's related to self-destruct. I know someone asked on Reddit. I do think there's good reasons to use self-destruct, but I was wondering, what are these good reasons? And one of the example I had is for CrowdCell's contract. Some CrowdCell's contract contain a whitelist, contain a large number of mapping variables, sometimes up to 10 to 20,000 of people joining in. And I was wondering how much do clients that run nodes are actually saving when you self-destruct these kind of contracts. So I know that on the blockchain itself, the contract data is still there, but the mapping is reoriented or something. I'm not super sure of how it works. But there has to be a reason why there's an incentive for people to call self-destruct. And my understanding is that you want people to call self-destruct by giving extra gas because you want them to free the blockchain from unused state variables or unused states in general. And I was just wondering, like, should it be a good practice to destroy contracts that will not be reused ever, such as token sell contract to save space?
Yeah, I think that self-destruct is a good sort of blockchain citizenship, in that it encourages people, if you're writing a contract and you can safely do so, like the crowd sale contract's an excellent example, then you should. But the problem, as you allude, is that at the moment it's poorly incentivized. And the reason for that is that when a miner mines a contract, it ultimately has to be able to be rewarded for the work it does. Otherwise, you open yourself up to DOS attacks. And that means that in practice, what we do is enforce that no more than half the gas. So you can get refunds for suiciding contracts, self-destructing contracts, deleting storage elements. In practice, those refunds are capped at half the gas that was used to execute the contract. And the reason being that we want to limit the DOS issues and the potential reduction in miner reward there. And because of that, and because there's no sort of deposit set aside, there's no deposit account for when you create a storage slot, the refund for self-destructing contract is a fixed fee, and it's not a particularly large fixed fee, regardless of how many storage slots your contract had. So the result is that the incentives to self-destruct the contract in purely financial terms are very slim indeed. And in fact, usually if you're going to self-destruct it, you're probably just going to call self-destruct on its own, which means that the refund, being limited to half the gas doesn't actually save you very much at all. So this is an open question, really. At the moment, there's very little reason from a purely selfish point of view to self-destruct your contract, but it is, nice citizenship. Just like there's very little reason to free up storage slots unless you're, using that refund to allocate new ones in the same transaction. But again, it's nice citizenship. A good example of this is as you allude with things like airdrops. The Omise Go airdrop added something like 30 megabytes permanently to every single, Ethereum client. And that cost them a one-off fee of, a fairly substantial amount of gas and ether to submit it all. But that's with us forever now because there's very little incentive for them to build it so that it can be freed up later. And this all comes into the question of storage rent. So in the long run, we're going to have storage rent that will, one way or another, incentivize freeing up data. But it's not really certain what it will look like yet, and there's a lot of problems to solve before we can get that far. Hopefully that was helpful.
Yes, very helpful. So you're saying that right now there's no incentive for me to do it except just being a good citizen of the blockchain. And
yes, pretty much. I mean, it is possible that at some point we will introduce storage rent that doesn't grandfather in existing contracts, and therefore those contracts, that you've already written may behave better and be more useful if you built them to be good citizens. But I'd say that's far from guaranteed.
Okay. Yeah, it's interesting. I'm following the rent discussions a bit, and it's going to be fun. Thank you.
Thank you. All right, so one final opportunity. Any other questions from the TV audience at home? I'll give everybody a minute or so, and if there's nothing else, then we'll sign off for the night. So we do have one question from the YouTube chat from Alex Medkix. I apologize if I'm butchering your name there. your opinion of a fee potentially being required in the future for keeping smart contracts deployed? Are there any other alternatives that help reduce bloating on the chain? I mean, this is the storage rent that we were talking about effectively. I think it's, whether we like it or not, it's probably inevitable. Paying a one-off finite fee to store data indefinitely isn't a practical long-run solution. And probably the only reason the Ethereum blockchain isn't bigger than it is because of limited gas and limited usage in the early days. So I think some form of rent is probably inevitable. There is one significant alternative that people have proposed, which is called stateless clients. And the idea there is that instead of every node on the Ethereum blockchain storing the entire state of your contract, transactions would have to include a cryptographic proof, probably using a Merkle hash or a Merkle tree, of all of the storage elements that contract needs to read and write. And then each node could verify that the transaction is valid purely based on the block hash of, the storage hash from that contract, and the Merkle proof and all the data that's needed, and then produce the same output, across all the clients, just like we currently do. And then it wouldn't actually store any of the output results. It would simply rely on people observing that transaction and replaying it themselves and storing the data if it's relevant to them. So on the surface, this is quite attractive, and I quite like the idea, because it means we can have contracts that store gigabytes of their own data, but don't need to actually impose that on everyone. You just have a set of interested parties. So all the CryptoKitties players store copies of the CryptoKitties database, but nobody else needs to. One of the significant issues with that is that it opens up to censorship attacks, and it can make life more difficult for people participating as asynchronously, joining the system later. So one very good example given by Vlad Zamfir was the example of you have, say, a last will and testament contract, and that has some state, and in order to call a function on it, such as give me my share of the estate, you need to call a function on it. Your evil uncle calls the function to get his set of silver spoons or whatever, when he knows nobody is watching the contract, and now he is the only one who is aware of the input state, and therefore the only one who can help other people call functions on that contract. So despite the fact that he was only entitled to something trivial, he can now prevent the current state of the contract. And there are potential ways around that, but most of them involve asking parties to watch the contract for you and so forth. I personally don't think that's necessarily fatal to the idea, and I'd love to explore it further. But others, including Vlad, are a lot more skeptical about it. So I personally think it's more likely we'll see rent proposals being successful than a stateless client, at least for the Ethereum main chain. JP Antunes asks, would it be feasible to tie the storage rent to the economic activity of the contract? For example, if a contract is very popular and generates X amount of fees for miners, perhaps it should cost less to keep. That's a really interesting idea. It's, that's economic activity in the sense of, the amount of interaction, not necessarily the amount of money passing through the contract, which is good because, of course, there are contracts like the ENS registry, to take a personal example, that see a lot of calls, but not necessarily any money passing hands. It's a potential avenue that's worth exploring. The problem is that you can't extrapolate from you have to be careful about extrapolating these things across the network, because a miner can have, or a validator can have, an incentive to invent their own transactions and lie about the activity of a contract. So, for instance, say a miner has a deal with the owner of a particularly large contract. They could agree that the miner will invent a transaction or two in each block to that contract, which doesn't cost the miner anything because the fees are paid from itself to itself. But in doing so, will sort of tweak the numbers to make that contract look a lot more popular than it is, which could reduce its fees, elsewhere. So mechanisms like that may have a place, but they need to be effectively restricted in scope to the place where the effects are actually taking place. So you could say that if there's a transaction against a contract, then the rent for that particular block is less, because the miner is the one who would be missing out as well. Yeah, so let's see. We're running out of time. We have time for just about one more question if somebody wants to butt in. All right. In the absence of that, I'd like to thank everyone who called in and left questions in the chat. Thank you for joining me on the first episode of The Corner Case. Apologies for the general mess and messiness. This is the first time I've done this, so let me know in comments on YouTube and Reddit and Twitter what you thought and whether you think this is worth continuing. Thank you very much, everyone.